Hello, my name is Andy Schweitzer, and this is a short video on every chemical has a name. That's our main idea here, and our sort of power standard. And every chemical in chemistry has a name. Therefore, every chemical you should be able to. Let me grab my pencil here. Um, to be able to have a name, some sort of structure, and from there, well, we have some types of formulas. And our last video talked about each of those, and we'll be advancing a couple of organic compounds in a little more complex ways to see their name, structures, and formulas. Today we're going to look at, on the side you see here, what are called functional groups. Bells and whistles, essentially. We're going to look at, what happens if you take another carbon chain off a carbon chain, alcohols, and acids. So all of this naming process essentially is the same. I am just highlighting a couple of them because they're all the same. These are real common in things we'll use in class, but they're all named the same. Essentially, is how long is your longest chain? That's called your parent chain. And then off of that, what do you have located on the parent chain, and where is it located on the parent chain? If you know where it is and what it is, you can basically create a name that's going to tell you what this structure looks like. So first thing we're looking at is carbon chains. We'll be using again this particular naming format. You'll see how that works. Let's try an example here. If we were to take carbon like this, so for carbon chain, we'll just take it, put something on here, another carbon. Okay. Again, I'm not showing all my hydrogens. There are several hydrogens here. There would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is going to be C5H12. That's the formula. So here we have our structure. Some might call that a Lewis structure, some form of it at least. This is my formula. And then we have, of course, the name. Now, what is this thing called? Well, first, my longest chain, I have 1, 2, 3, I have 4 carbons in a row now. Again, it would be, this is 4 carbons in a row. I could use this carbon here. It doesn't really matter. Okay. Take your longest chain you have. So carbon, 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 carbon. That's 4 carbons. So this is going to be, it's all single bonds. So we're going to call this thing butane. Now this is what this would be called, butane. Now I got to tell anybody who's looking what is located on my chain and why. Well, I have this, this another carbon group on here. So I count from the shorter side, or the side that gives me the smallest number. So I'm going to count from first carbon, second carbon. So on my second carbon, I have 1 carbon. So I call it 2-methyl. 2-methyl butane is the name of this guy. And again, if I wanted to convert this back, I would say, okay, well, my longest chain is butane. 1, 2, 3, 4. And on my second carbon, I have a single carbon group. So I can count from either side. I can say, well, 1, 2. Okay, so, and I could put on the bottom, or I could put it on top. I could go right here, like that. All right, so my first carbon and my second carbon. Again, there's hydrogens all over here. And this is 2-methyl butane. Another way of drawing this would be simply using just my ball and stick method. Right, that's butane, and you draw a little guy off like that. That is another way of showing 2-methyl butane. So carbons, again, hanging off of chains, simply call it the longest possible chain. And there are a lot of little examples that you can work through to see how this works. Let's take a moment and let's, okay, so I can give myself some room here. I just want to do that. All right. Give myself a room. All right, let's go like this. Let's go 1, 2, 3, 4, 5, 6, okay, 7, 8, 9, okay. Let's go with one more, okay, right here. Again, I am zigzagging all right, it doesn't really matter. It's not really showing its spatialness in 3D anyways, so I count my longest chain. My longest chain is going to be 1, let's go 1, 2, 3, 4, 5, 6, oh. Let's try it again. I'll back it up there. That was not the longest. 1, 2, 3, 4, 5, 6, 7, 8. That's my longest. So this is actually a unique looking octane. And then I count from the shortest end, which is going to be 1, 2, 3, and 4. So on the fourth carbon, I have another little 2 carbon group off this. So I go 2 ethyl, dash there, 2 ethyl octane. I can go, well, let's try another example. Let's go to alcohols. Now an alcohol is simply when you have the OH, and sometimes I write it as like this, OH, without the dash there. Oxygen generally bonds twice, so I could have carbon OH. This is the simplest alcohol. It's called methanol. So in this case, we tell the, how long is my biggest chain? That's going to be meth, okay, and that's the base word for 1 carbon. And then we need to use a suffix to tell that there is in fact an alcohol here. Now alcohols use the suffix -ol, -ol. So this is meth and -ol, methanol. We don't need to give a location because there is only 1 carbon. The location would be simply given as 1 dash, 1 methanol, which again you'll never see because there is only 1 carbon. If I were to go another example here, let's say we have carbon, carbon, OH. This is the longest chain is F, or ethyl, eth, and all. Again, you don't see 1 ethanol. Whatever side it's on the first one. If I go 3 carbons, 1, 2, 3, now I have an option. I have my first carbon, I have my second carbon. Remember which way I count, I'm always going to be on the first, second. I would never get to 3 unless I have more than 1 alcohol on this thing. So let's just say it's in the middle. Okay, carbon, 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 and top and bottom does not matter. This is going to be 2 dash propanol. 2 propanol. Again, if I were to have, let's say, let's see myself a little room here. Let's say I want to go from the name to the formula. Okay, let's go with 3, I don't know, hexanol. Then I say, okay, my longest chain is 6. So 1, 2, 3, 4, 5, 6. And then I have an alcohol on the 3rd carbon. Doesn't matter which way you start from. 1, 2, 1, 2, 3, and OH. I could continue the rest of my hydrogens if I want to write a formula out. This guy's got 1, 2, 3, so there's 1 more hydrogen on there. Another one, and we'll go with that guy. So we got, in this case, it'd be C, 6, and then H. How many H's? We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, H, 13. And they usually write this guy like this, just to give the viewer some option of like, there's an alcohol on this thing. Does it tell you where? No. But the name, again, would be something that would give me more of an idea, or an exact idea of what this thing is. We have a very specific structure and a very specific name. The formula can sometimes be misleading. This thing could have be several different alcohols. I could put this alcohol on any one of the carbons and it would be a different substance. An acid. Okay, now again, we haven't dealt too much in acids yet. You probably have some idea what an acid is, but we're looking at, it's called an organic acid. Now, an organic acid has this substance on it, or this functional group. It takes a carbon It has a double bonded oxygen on it, and then it has what looks like an alcohol, but with this double bonded oxygen on here, this is commonly referred to as a carbonyl. But the carbonyl group on here, it basically drains this bond right here of electrons and makes it weak, and the hydrogen can often be lost to the environment, and that is what makes it acidic. And we'll end with something like this, and a little negative charge because it lost an H and a positive. So either way, and then this just connects to the chain. So an organic acid is always on the end. We can so for example, the simplest organic acid is just what we have here, OH, and this is just hydrogens. So this is going to be called methanoic acid. And essentially, we just end up getting a little bit bigger. We have 2 carbons. This is going to be ethanoic acid. This is commonly referred to as vinegar. Okay. It has carbon here, carbon here, carbon here. Sorry, this one does not have one because it's 1, 2, 3, 4. Okay. So we'd write this out as CH3 COOH, and that is a common way to write ethanoic acid. Methanoic acid would just be CH2OOH. That's another way of doing that guy. Once this particular ethanoic acid loses its H, it becomes carbon, carbon, and just plain old O, and I could put a negative charge in that if I want. Somewhere it's there. So this guy, rather than being, would now be CH3COO negative. This is called, well, this is called ethanoic acid right here, but this is called acetate. So they give this little 8 version on the end once it loses its H. So again, we just, because it's always on the end, we don't really have to tell where it's located because it's always on the end. So acids are quite simple. We have this little functional group right here that's on the end of it. And simple as that. Thank you very much.